Hello guys and welcome back. So I wanted to talk about the substepping and the challenges that we face generally when we want to emit from a moving object. And I'm going to start by adding a point. I'm going to use the pop context to illustrate this. So I'm going to have the object move left and right. I'll use the sign of frame. Let's use the FF in case we wanted to do substeps, and that should give us some value. Okay, it's not at, it's the dollar sign. Cool, so the object is moving, the point is moving, and let's increase that by 10. And let's increase the distance so it moves, it covers a bigger range. Cool. And I want to emit from that. Actually, I want to make it even faster. So let's try, or let's leave it for now, and then we'll change it to illustrate the substepping effect. So I'm going to create a pop network. I'm going to use the object, and we're going to use all points. And we'll leave it at that. So let's lower the expectation, the life expectancy to 1 second, and see what we're getting. So right now, as the source starts moving, you can see we're only getting points emitted in those locations. So let's put down a gravity node. And you can see the object is moving from left to right, and you can see the gaps. We don't get a straight line. It doesn't. We cannot form a straight line with this fast-moving object. The solution for that is to increase the substep. So we evaluate 10 times between every frame instead of one. And in this case, you can see it's forming pretty much a line, but now it's 10 times slower. So if we need to get a straight line completely, we need to increase this, and the sim now is 20 times slower, and it's going to use more memory. So this is not ideal, and in pops there is a workaround for this. And if we compute the velocity for this guy, so I'm going to use a trail node, compute velocity, and then I'm going to set it back to 1. And here under the birth, there is this option to jitter birth time, and we can change it to positive or negative. We're gonna leave it for positive for now, and we can tell it to interpret the source backward or forward. So I'm gonna use backward, and there's two options: either match topology if you have a static, if the input geometry topology is not changing. But in this case, we're going to use the point velocity. So if we hit play, it works better. But let me turn off the velocity so it doesn't shoot points straight. So it's a little bit better. The points are not exactly at the same location, but we're still having the same issue. So let's try forward. Same. Let's try negative. Yeah, so basically that's what we can get. We can jitter the birth time, and in most of the cases, if you have like a continuous emission or multiple points, this method generally helps. But with DOPs, we don't have that. If we have a sphere, and then we do VDB from polygon, this guy, and actually let me copy this. Or you know what, I'm gonna create a new one to illustrate this. So if we create a sphere, and then let's use the shelf tool. Where is it? Pyro. Let's say billowy smoke, and select the object and hit enter. I just need a DOP setup, and let's add some movement to the object. So okay, it added it here, that's fine. I'm gonna delete this guy. So let's add movement to the sphere. And let's copy the expression. Okay, cool. Let's go back to the dot network and let's increase the bounding box to cover the entire range, and let's turn off the resize. So if we hit play, we're gonna see this the stepping, and the sphere is not moving too fast, and the faster it gets, the more gaps we're gonna see between the dots. So let's increase this. Actually it's here. Let's reset the network because it's cached. Cool. So basically it's not going to fill the gaps in between the sphere states, and the solution for that is to go inside the solver, and under the advanced we need to increase the min and max substeps, and that will basically force it to do 3 substeps and then up to 5 based on the speed of the object. There is other method to also smudge the fluid source using the fluid source node. So here under the fluid source there is a motion blur section that can blur the source, but it's not perfect, especially that we're going to have a lot of fine emitting objects. It's not just so in this case it's not just a big object moving, we have a lot of fine details that we want to capture, and none of these methods will work. So we need to set up something that solve these cases, and for now we're going to start creating the system that will emit these points, and then from there we'll generate the path and provide the DOPS, the data that it needs, so that we don't have any substepping issues, or we don't have to increase it to something really high to get a nice details, tendrils, or projectiles. Thank you for watching, and see you in the next video. Bye bye.